Studying dinosaurs is hard, not just because it can be a challenge to go out to the field and excavate the bones, but because the bones we get are often broken and don't come as part of a complete skeleton. Occasionally, we'll get lucky, and we'll find something as beautifully preserved as this skeleton housed at the Canadian Museum of Nature. But most of the time, what we get looks a lot more like what we see on the left. A couple of broken bones, maybe scattered with a few other broken bones. Yet, we don't know what species this skeleton belongs to, while these few skull bones are enough to define an entire species. Why? Because the study of this group of dinosaurs, a group called ceratopsids, and including the famous Triceratops, has focused almost exclusively on the skull. That means if you don't get a skull, you don't know what species you're working with, even if you have every other bone in the body. My research is working to change this imbalance. For years, paleontologists have had this focus on the skull because they've assumed that bones besides the skull look the same in different species. I've been testing this idea by going to museums throughout Canada and even in the US, looking at the bones that they have on display and behind the scenes, taking pictures, making measurements, making notes. And what I've found is that there actually is a lot of variation between specimens. For example, the largest bone in the pelvis, called the ilium, highlighted here in yellow, is strongly curved and S-shaped in some species, but nearly straight in others. Another bone in the pelvis, highlighted in orange, has a blade sticking off the front that has a different shape in different species. A bone in the lower leg, highlighted in green, has a part sticking off to the side that in some specimens is straight and in others is curved. These sorts of variations, though sometimes very subtle, are how paleontologists determine what different species are and how those species are related to each other. More similar species are more closely related to each other. The next steps for my research are to take the variation that I found and see what that tells us about the relationships and therefore evolution of these animals. My initial results show that some of the variation that I found maps really, really well with our current understanding of how these animals are related to each other. But other variation doesn't match so well, suggesting that perhaps there's a more complicated picture when it comes to the relationships and evolution of these animals. This research is opening the door for new discoveries by starting a conversation about the legs and pelvis of these animals. In the future, when paleontologists think of this group of dinosaurs, hopefully they'll think about more than just the skull and ask questions about the rest of these animals' bodies. Because after all, these animals do need their legs too. Thank you.